Okay, let's unpack this artificial intelligence thing. I mean, one minute it's just, robots in movies.
Right. Sci-fi stuff.
Yeah. And the next, it's actually helping write our emails, maybe even making battlefield decisions down the line. It feels like more than just another gadget.
Oh, absolutely. It feels like a genuine turning point.
And that's exactly what we're diving deep into today. Our mission here really is to give you the core understanding of AI
Its history, the impact it's having.
and where it might be going, right?
Yeah.
But without getting totally lost in the tech jargon.
It's fascinating, though, because this huge leap we're seeing now, as our sources detail in this report, AI, history, impact, regulation,
Hmm.
it's actually been building for decades.
Yeah, it's not an overnight thing, even if it sometimes feels like it.
Not at all. It's a story with some surprising twists and turns, actually.
Totally. And speaking of our guide here, for this deep dive, we're leaning heavily on that report, AI, history, impact, regulation.
It's pretty comprehensive.
Think of us as, I guess, your interpreters, highlighting the really crucial bits. We'll trace AI right back to the start, the initial ideas.
Uncover why it's exploding right now.
Yeah, who the big players are, what it's actually being used for, including some pretty serious military applications we need to talk about.
Then map out the global picture, the competition.
And tackle those big, big questions. The opportunities, sure, but also the risks.
Ethical stuff, even existential questions.
Definitely. And finally, we'll look at how we're trying to, well, manage it all. Governance, regulation, and how it's changing the way we learn and maybe even develop as people.
Sounds like a plan. So where do we start? The basics.
Yeah, let's start there. So fundamentally, what is AI according to the report?
Well, the report defines it pretty clearly. It's essentially the capability of machines to perform tasks that normally require human intelligence.
Like what sort of tasks?
Things like reasoning, figuring things out, learning from experience, solving problems, understanding language.
Talking, basically.
Yeah, understanding and generating language. And also perception, like seeing and interpreting the world.
Okay, so it's broader than just automation. It's about machines having these cognitive-like abilities.
Exactly. And to really get that, we need to understand a few core concepts the report breaks down. First up, machine learning.
Right. I hear that one all the time.
So machine learning, or ML, is where the AI learns from data without needing explicit programming for every single step.
Okay, so you don't tell it exactly what to do, it just learns.
Kind of, yeah. Think of it like showing a kid lots of pictures of cats and dogs until they can tell the difference on their own just by seeing enough examples. It learns the patterns.
Gotcha. And deep learning, is that just more learning?
It's a type of machine learning, yeah, but it uses these really complex structures called neural networks, often with many layers. That's the deep part.
Neural networks, that's another big one.
Right. Deep learning excels at finding incredibly intricate patterns in huge data sets. Think recognizing not just a cat, but a specific breed of cat in millions of photos, or understanding the nuances of spoken language.
Okay, so ML is learning from data. Deep learning is doing that with complex neural networks for massive data. What about the neural networks themselves?
So neural networks are the algorithms underneath, inspired loosely by the human brain's structure. They're designed to recognize patterns. Imagine like a web of connections.
Right.
Data flows through, and different connections activate based on the patterns they detect, eventually leading to an output, like identifying an object or translating a sentence.
Right, so it's pattern recognition machines, essentially. And then there's natural language processing.
NLP.
Yep, NLP, that's all about AI understanding and generating human language. It's what powers, translation tools, chatbots, voice assistants.
It's like Siri or Alexa understanding me.
Exactly, and also being able to respond coherently. And the last key one mentioned is computer vision.
Letting machines see. Pretty much, interpreting images and videos. Think facial recognition, or how a self-driving car identifies pedestrians and traffic lights.
Okay, that makes sense.
Yeah.
ML, deep learning, neural networks, NLP, computer vision, those are the building blocks.
And the report makes an interesting distinction between different levels of AI.
Oh yeah, like what?
Well, most of what exists today is called narrow AI, or sometimes weak AI.
Narrow because?
Because it's really good at one specific task, or a narrow set of tasks, like playing chess, or recognizing faces, or recommending movies, but it can't do things outside its specialty.
Right, so your chess program isn't going to suddenly start writing poetry.
Exactly. But the long-term goal for many researchers is artificial general intelligence, or AGI.
The general part sounds important.
It is. AGI would theoretically have human-like cognitive abilities across a wide range of tasks. It could
Wow.
learn, reason, and adapt to pretty much any intellectual challenge a human could.
Wow, so like the AI from the movies, almost?
That's often the comparison, yeah. And then even beyond that, there's the concept of artificial superintelligence, or ASI.
Superintelligence, that sounds intense.
It is. ASI would be an intellect that vastly surpasses the brightest human minds in practically every field, solving problems we can't even comprehend right now.
Okay, that's heading into really mind-bending territory. So we're mostly dealing with narrow AI now, the specialists.
Correct. Highly capable specialists, but specialists
And
nonetheless.
the report really emphasizes the speed, the exponential growth of this field, comparing it to Industrial Revolution.
It does, yeah. Highlighting the potential impact on the global economy. We're talking trillions of dollars. It gives you a sense of just how transformative this technology is expected to be.
It really does. So how do we get here? Let's rewind a bit. The history.
All right. The report actually takes us back even before the 1950s to the early ideas, the foundations.
Like way back. Myths and stuff.
Yeah, it touches on ancient myths of artificial beings and early sci-fi like Fritz Lang's Metropolis or Asimov's I, Robot. These sort of planted the imaginative seeds.
Gotcha. The cultural imagination.
But then it gets into the more concrete theoretical work. Alan Turing's concept of a universal machine in the 30s was absolutely foundational.
The idea that one machine could, in theory, compute anything computable.
Precisely. And then in the 40s, you had McCulloch and Pitts proposing the first mathematical model of an artificial neuron.
Wow, the 40s.
Yep. And Donald Hebb's theory about how learning might happen in the brain through strengthening connections between neurons that fire together, wire together.
So these weren't AI labs, but the fundamental ideas were emerging.
Exactly. These abstract concepts laid the groundwork for what came next, which the report really marks as the birth of AI in the 1950s.
And the key event there was?
The Dartmouth Workshop in 1956. That's where John McCarthy actually coined the term artificial intelligence.
So that was the moment it became a defined field.
Pretty much, yeah. It brought together the key researchers and essentially launched AI as a formal area of research. It was a shift from just theory to, okay, let's actually build intelligent machines.
And Turing was still influential then too, right, with his imitation game.
Absolutely. The Turing test, proposed in 1950, it's still debated today, but it provided a tangible, if controversial, benchmark for thinking about machine intelligence.
And were there actual AI programs back then? Or was it still mostly theory?
Oh, there were early programs. The report mentions Arthur Samuel's Checkers program from the 50s.
Checkers. Seems simple now.
Maybe, but the amazing thing was it could learn from playing games against itself in humans, getting better over time. A really early example of machine learning.
That is cool. What else?
There was the logic theorist, developed by Newell, Shaw, and Simon. It could actually prove mathematical theorems from Principia Mathematica.
Seriously, in the 50s. That's impressive.
Definitely. And early work on neural networks, too, like Rosenblatt's Perceptron and Widrow and Hoff's Adeline. These were basic but crucial first steps.
So a lot of excitement and early progress. But it wasn't all smooth sailing, right? You mentioned AI winters.
Ah, yes. The report covers those periods, mainly in the late 70s and then again in the late 80s, early 90s.
What happened? Did people just lose interest?
It was more complex than that. A big factor was, well, hype. Early researchers made some very optimistic predictions that didn't pan out quickly.
Overpromising.
Kind of, yeah. Combined with limitations. The computers back then just weren't powerful enough for the really complex tasks, and the algorithms had hit roadblocks.
Like the combinatorial explosion problem. Too many possibilities to check.
Exactly. And when the promised breakthroughs didn't materialize fast enough, government funding, particularly from agencies like DARPA in the US, got cut significantly. That's the winter.
But research didn't completely stop.
No, crucial work continued, often on a smaller scale or focusing on different approaches. It laid the groundwork for the eventual thaws.
And the first thaw came in the 80s.
Right. Driven largely by the rise of expert systems.
What are those?
AI programs designed to mimic the decision-making ability of a human expert in a specific domain. They were based on encoding expert knowledge as rules.
And they worked.
Some were very successful commercially. The report mentions XCON at Digital Equipment Corporation, which configured computer systems and reportedly saved the company millions.
Ah, money talks. That would get attention.
Definitely. It showed AI could deliver tangible business value. Then the 1990s saw another important shift, the rise of machine learning becoming more central.
Moving away from just hand-coded rules.
Yeah. Key algorithms like backpropagation, which allowed neural networks to learn more effectively, became more widely used. And techniques like support vector machines, SVMs, and decision trees gained traction.
And we started seeing those big milestones again, right?
Absolutely. IBM's Deep Blue defeating Garry Kasparov in chess in 1997 was huge psychologically.
Yeah, I remember that. Front page news.
And the DARPA Grand Challenges in the mid-2000s really pushed autonomous vehicle technology forward.
Getting cars to drive themselves across the desert.
Exactly. Plus, you had influential robots like Kismet at MIT exploring social interaction, and NASA's Mars rovers, Spirit and Opportunity, navigating another planet autonomously.
So the building blocks were accumulating, the winters were over, leading us to the current boom.
Precisely, which the report really pins starting around the 2010s, calling it the deep learning revolution.
And the spark for that was?
A pivotal moment in 2012. A deep learning model called AlexNet, developed by Hinton's group at the University of Toronto, won the ImageNet competition by a huge margin.
ImageNet, that's the massive image recognition challenge.
Right. AlexNet's success demonstrated the power of deep learning, particularly with GPUs for computation, on complex, real-world data. It changed everything.
Okay, and that paved the way for?
The rise of large language models, LLMs. Models like Google's BERT and OpenAI's GPT series built on architectures like the Transformer.
Transformers, they seem key to the language stuff.
Hugely important. They allow models to weigh the importance of different words in a sentence, leading to much better understanding and generation of text.
And then, bam, 2022, ChatGPT arrives.
And generative AI suddenly becomes mainstream. Everyone starts using it, talking about it. It felt like an overnight sensation, but it was built on decades of progress.
Decades of progress culminating in this
Yeah.
explosion. So what are the key ingredients of this current boom, according to the report, the catalysts?
The report really highlights three crucial enabling technologies coming together. First, data, sheer amounts of it.
Big data.
Exactly. The internet, social media, sensors. We generate astronomical amounts of data now. And this data is the fuel for training these large AI models.
So we can store it now too, right? Cloud computing helps there.
Massively. Cloud storage makes managing and accessing these enormous data sets feasible for more people and organizations. So data is number one.
Okay, what's number two?
Computational power. Training these huge models, especially deep learning models, requires immense processing power.
This is where the GPUs come in, graphics cards.
Precisely. Graphics processing units, originally for video games, turned out to be incredibly efficient at the parallel computations needed for deep learning.
Thanks to companies like NVIDIA.
NVIDIA became absolutely central, and now we're seeing specialized AI chips too, like Google's TPUs, designed specifically for these tasks.
So massive data and the horsepower to process it. What's the third piece?
Algorithmic innovation. The methods themselves have gotten much better.
Like the deep learning techniques we mentioned.
Yeah, refinements in deep learning, new architectures like the Transformer model.
Which powers the LLMs.
Right. And also improved training methods, backpropagation, reinforcement learning, where AI learns by trial and error, even things like federated learning.
Federated learning, what's that?
It's a way to train models on decentralized data, like on people's phones, without the raw data ever leaving the device. Good for privacy.
Okay, so it's a tech trifecta. Big data, powerful compute, and smarter algorithm.
That's the core technological foundation, yeah.
Yeah.
But the report also points to major economic drivers.
Money, again.
Well, yeah. Massive investment is flowing into AI. Venture capital funding reportedly topped $100 billion in 2024 alone.
Wow. Why such huge investment?
Because businesses increasingly see AI not just as an advantage, but as a strategic imperative.
Yeah.
Essential for staying competitive.
It's like if you're not using AI, you're falling behind.
That's the perception in many industries. And another factor is the democratization of AI tools.
Making it easier for more people to use AI.
Exactly. Cloud platforms like Amazon's AWS, Microsoft Azure, and Google Cloud offer powerful AI services on demand. You don't need your own supercomputer anymore.
Renting the capability.
Right. And also the open sourcing of major models like Meta's Llama series.
Why is open sourcing so important?
It puts powerful tools directly into the hands of researchers and developers everywhere, accelerating innovation and experimentation way beyond just the big labs.
So lower barriers to entry, fueling more activity. And this creates a whole AI ecosystem.
Definitely. The report outlines it. You've got the hardware makers like NVIDIA and AMD, The cloud giants providing the platforms, the foundation model developers like OpenAI, Google, Anthropic, Meta,
The ones building the core AI engines?
then companies building specific applications on top of those models, plus universities and research labs. It's a whole complex web.
And there's a feedback loop, right? Better models lead to
Better models create more value, attract more investment, which fuels more R&D, leading to even better models. It's a powerful reinforcing cycle.
a virtuous cycle driving progress. But the report adds a slight nuance there about hype versus actual spending.
Yeah, that's an interesting observation. It notes that while corporate talk about AI surged after ChatGPT, the correlation with their own direct capital expenditure on AI infrastructure might have weakened slightly.
Meaning,
It suggests companies might be increasingly relying on partnerships, using those cloud AI services, or acquiring AI startups rather than making huge internal investments in building everything themselves.
so maybe leveraging existing platforms more than building from scratch? Seems practical?
It could be a more flexible, less capital-intensive approach in such a fast-moving field.
Makes sense.
Yeah.
Now, the report also dives into the global competition, especially US versus China. They seem to be the main contenders.
They're definitely the dominant players, yeah. But the report highlights they have different strengths.
How so?
The U.S. generally leads in private investment significantly more VC money. It also leads in developing those really high-impact, notable foundation models. Think GPT-4, Gemini, Claude.
So leadership in cutting-edge research and funding. What about China?
China leads significantly in the sheer number of AI-related patent filings. And also in adoption rates businesses, there seem to be implementing AI, especially generative AI, very rapidly.
So US leads on the frontier models and investment. China leads on patents and deployment speed. Interesting contrast.
It suggests different national strategies. The report includes a table comparing metrics like investment, notable models, patents, government initiatives, even data center capacity.
And what does that table show overall?
It underscores the U.S. lead in investment in top models, China's lead in patents, and highlights China's massive government push and investment in infrastructure like data centers, even if the U.S. currently has more capacity. Really paints a picture of intense competition across different dimensions.
A real race for AI dominance. Okay, let's zoom in on some of the key players shaping this landscape. The report mentions several big corporations.
Yeah, it starts with the tech giants, as you'd expect. Google, for instance. With DeepMind and their Gemini models, they've been a research powerhouse for years, reportedly pouring something like 70% of R&D into AI.
70%, that's huge. And Microsoft.
Microsoft's big play includes their massive partnership with OpenAI, integrating models like GPT into their Copilot tools and Azure Cloud Platform. They're also spending heavily, over 60% of R&D potentially on AI.
So they're not just using AI, they're fundamentally restructuring around it. What about NVIDIA?
They're different. Totally different role, but maybe just as crucial. NVIDIA provides the picks and shovels, the GPUs, and the CUDA software platform that almost everyone uses to train and run these big models.
The essential hardware layer.
Exactly. They call themselves an AI factory. Their new Blackwell chip architecture is a huge deal. Their R&D reflects that foundational role.
And OpenAI, obviously. The ones who really brought generative AI to the masses.
Right, led by Sam Altman. Their mission is focused on achieving artificial general intelligence, AGI, and ensuring it benefits humanity. Huge influence.
And Meta, Facebook's parent company.
Meta has its own highly respected research lab, ALIAR, and they've made waves by open sourcing their Llama models, driving a lot of innovation. Plus, AI is core to their social platforms and their metaverse ambitions.
Interesting strategy with the open sourcing. What about Amazon?
Amazon's huge through AWS, their cloud division offering tons of AI services. They also have Alexa, of course, and a major partnership with Anthropic, another leading AI lab.
So cloud infrastructure and partnerships.
Okay.
IBM. They were early pioneers with Watson.
IBM still focuses heavily on enterprise AI solutions with Watson X, and they hold a massive number of AI patents. They're a long-standing player.
And Apple. They seem quieter on AI.
They tend to be, but AI is deeply embedded in their products. Siri, computational photography, predictive text. They also acquire a lot of AI startups and are pushing towards more powerful on-device AI.
So it's woven into their ecosystem. The report mentions others too, right? In specific areas.
Yeah, briefly, companies like Salesforce using AI for CRM, Adobe for creative tools, numerous startups in drug discovery using AI. Others in defense AI, competitors to OpenAI like Anthropic and Cohere, AI video generation, AI search, it's everywhere.
It really drives home how pervasive AI is becoming, but it also highlights, well, a lot of power concentrated in a few big tech companies.
That's a major point the report makes. This concentration raises big questions about competition, market access, and who ultimately controls this transformative technology.
Definitely something to keep an eye on. Beyond the companies, who are the key people the report mentions? The influencers.
It covers a range, from the historical pioneers like Alan Turing, John McCarthy, Marvin Minsky,
The founders of the field.
right, to the so-called godfathers of AI, Geoffrey Hinton, Yann LeCun, Yoshua Bengio, who won the Turing Award for their work on deep learning. Their contributions are fundamental.
The ones who really drove the deep learning revolution.
Exactly. Then you have the current leaders, Sam Altman at OpenAI, Demis Hassabis leading Google DeepMind, Andrew Ng, who's done so much for AI education through Coursera and other initiatives.
Making AI knowledge accessible.
Hugely important. Jensen Huang, the CEO of NVIDIA, is incredibly influential because his company's hardware is so critical.
The hardware kingpin.
You could say that. Fei-Fei Li, who created ImageNet, which was so vital for computer vision progress. Peter Norvig, co-author of the Standard AI textbook.
Wow, quite a list. Any others?
Yeah, thinkers like Cassie Kozyrkov on decision intelligence, Ian Goodfellow, who invented GANs, generative adversarial networks, Kai-Fu Lee on U.S.-China AI dynamics, Andrej Karpathy, known for his work at Tesla and OpenAI,
A real mix of researchers, engineers, educators, leaders.
and corporate leaders making strategic decisions, plus policymakers shaping regulations, like Arati Prabhakar and Gina Raimondo in the U.S., Thierry Breton in the EU, Lena Khan at the FTC. It's a diverse group pushing things forward.
And all this activity needs fuel money. The funding landscape sounds pretty wild.
It's staggering. As we mentioned, VC investment hitting over $100 billion in 2024. That's just venture capital.
What about the big company spending?
Corporate R&D is also massive. Google and Microsoft, as noted, dedicating huge percentages of their multi-billion-dollar R&D budgets specifically to AI.
And governments, are they investing too?
Definitely. The report highlights major government initiatives. The U.S. has programs through the National Science Foundation, DARPA, Department of Defense. China has its new generation artificial intelligence development plan with massive state backing.
So a national priority for them.
Absolutely. The EU has its own AI innovation strategies. And countries like South Korea, India, the UK, Canada, they all have significant government funding programs recognizing AI's strategic importance.
So it's VC money, betting on startups, big tech pouring money into development, and governments funding research and strategic goals. A well-funded revolution.
You could definitely call it that. Which brings us to, well, what's the actual purpose of all this? What are the applications?
Right. What's AI actually for? The report contrasts the original kind of grand goals with what we have now.
Yeah, the early dreams were often about creating that human-like AGI. But the reality today is that the biggest impact comes from highly effective but specialized narrow AI.
Doing specific things really, really well.
Exactly. The report lists core capabilities: pattern recognition, prediction, automation, understanding and generating language, NLP, creating content.
Like images or text.
Right, and then it details applications across basically every sector. Think about the internet and e-commerce.
Recommendations, search results.
Targeted ads, translation, facial recognition for tagging photos. It's deeply integrated.
We almost take it for granted now. What about healthcare? That seems like a huge area of potential.
Huge. AI is being used for analyzing medical images, helping with diagnostics, and as the report highlights, it's having a massive impact on drug discovery.
How so?
Companies like Exscientia, Atomwise, Recursion, In Silico Medicine, Benevolent AI, Path AI, they're using AI to analyze vast biological data sets, predict how molecules will behave, identify potential drug candidates much, much faster than traditional methods.
So potentially speeding up new cures.
That's the promise, potentially shaving years off development times and enabling more personalized medicine tailored to individual genetics or conditions.
That feels incredibly significant. What about finance?
Algorithmic trading, fraud detection, credit scoring, robo-advisors managing investments. AI is already deeply embedded in the financial industry.
Transportation, obviously self-driving cars, but what else?
Optimizing logistics and supply chains, traffic management systems, predictive maintenance for vehicles.
Manufacturing too.
Yep. Predictive maintenance for factory equipment, quality control using computer vision, optimizing production processes, robotics, obviously.
And education. We touched on that.
Personalized learning platforms adapting to student pace, AI tutors, automated grading to free up teacher time, even AI-powered tools for creating educational content.
Entertainment and media.
Generative AI creating images, music, video, recommendation algorithms for streaming services, personalized news feeds,
Cybersecurity.
detecting threats, identifying anomalies in network traffic, automating responses to attacks. It's an ongoing arms race between AI-powered defense and AI-powered attacks.
Wow, it's really touching almost everything. Does the report mention AI for good uses?
It does, briefly. Things like using AI for environmental monitoring, tracking deforestation or wildlife populations, helping achieve the UN's Sustainable Development Goals, improving access to essential services in underserved regions.
So it has potential beyond just commerce and industry,
Absolutely. And the report explains the economic engine behind it all. AI creates value, efficiency gains, new products, cost savings,
which generates revenue or saves money.
which then gets reinvested into more AI research and development. It fuels itself.
And the ROI numbers mentioned are pretty striking.
Yeah, figures like generative AI potentially returning $3.70 for every dollar invested, Microsoft's Copilot showing huge ROI and productivity gains, billions in potential cost cuts for finance.
And that reinvestment rate for startups, 45%, reinvesting over 60% of revenue. That shows strong belief.
It really does. Now, should we move into a perhaps more complex and sensitive area, AI in the military?
Right. This is where things get really heavy. What does the report say about current and developing military uses?
It's already being used quite broadly. For intelligence, surveillance, and reconnaissance ISR. The report mentions Project Maven in the U.S. using AI to analyze drone footage.
Okay, analyzing data feeds. What else?
Logistics and predictive maintenance for military equipment, like the DART program. Cyber warfare, both offensive and defensive. And increasingly, autonomous systems.
Drones, ground vehicles.
Exactly. Autonomous drones, unmanned ground vehicles, UGVs, unmanned underwater vehicles, UUVs, also enhancing command and control systems, improving training simulations, and target recognition systems like Aegis on ships or newer AI-powered systems.
And the trend is towards more autonomy.
That seems to be the direction, yes. Which leads directly to the most controversial aspect, lethal autonomous weapon systems, or laws.
Weapons that can kill without a human pulling the trigger.
Essentially, yes. The report defines them as systems that can independently search for, identify, select, and engage targets without direct human intervention in that final lethal decision. The human out-of-the-loop scenario.
Are these actually deployed now?
It's debated. The report mentions some systems, like Israel's Harpy anti-radar drone, as potential existing examples, though definitions can be tricky. But the technology is definitely advancing.
What's the official U.S. stance?
Current U.S. Department of Defense policy, DoD Directive 3000.09, emphasizes the need for appropriate levels of human judgment over the use of force, but it doesn't outright ban laws' development. It sets requirements for their development and use.
So development is happening, but with guidelines. The report outlines arguments for and against these systems.
It does. Proponents argue laws could be faster, more precise, react quicker than humans in complex situations, reduce risk to soldiers by sending machines into danger, and operate in environments too hazardous for people.
Speed, precision, less risk to your own forces. What are the arguments against?
They are significant. Major ethical concerns about delegating life and death decisions to machines, big questions about compliance with international humanitarian law, particularly the principles of distinction, telling combatants from civilians, and proportionality, avoiding excessive civilian harm.
Can a machine really make those nuanced judgments in the chaos of war?
That's a core question. There's the accountability problem: who is responsible if a LAWS makes a mistake? The programmer, the commander, the AI itself. It's the black box problem again.
Right, if you don't know why it made the decision.
Exactly. There are also fears about lowering the threshold for going to war, risks of unintended escalation if autonomous systems react unpredictably, proliferation to non-state actors, and deep moral objections related to the Martens Clause in IHL about principles of humanity.
A lot of very serious concerns. Are there efforts to govern this?
Yes. The report mentions ongoing discussions at the UN Convention on Certain Conventional Weapons, CCW, though progress on a treaty has been slow. There's also the U.S.-led political declaration on responsible military use of AI and autonomy, endorsed by about 60 states now.
So, attempts at international norms. And the report asks this provocative question. Is AI the new atomic weapon?
It's a powerful analogy used to convey the potentially transformative and catastrophic risks. The report explores the parallels.
What are the similarities?
Both represent potentially revolutionary military technologies with catastrophic risk potential. Both are dual-use, useful for civilian and military purposes. Both emerged in a context of great power competition, raising fears of an arms race. Some, like Yuval Harari, argue AI autonomy is uniquely dangerous.
But the report also highlights key differences.
Right.
It's not a perfect analogy.
Crucially, yes, AI technology is generally much easier to copy and proliferate than nuclear weapons technology and materials. Access is wider.
Development is different too. Nuclear weapons were state projects.
Mostly, yes. AI development is much more diffuse. Private companies, universities are key players globally, not just governments. The dual-use nature is also blurrier. An algorithm for image recognition can be used for tagging photos or targeting weapons.
And the threat itself is different, not just mutually assured destruction.
Right, AI risks are more varied: bias, manipulation, accidents, loss of control, not just a single type of existential threat like nuclear war. Verification and control are also incredibly difficult compared to tracking nuclear materials or tests.
So the analogy highlights the scale of impact, but maybe oversimplifies the nature of the challenge.
That's the takeaway. It's useful for conveying seriousness, but AI presents unique governance challenges due to its decentralized nature, rapid spread, and the difficulty of control and verification.
A complex picture. Okay, let's pull back to the wider global landscape again. We talked U.S. versus China, but what about other players?
The report details U.S. strengths research quality, those notable models, 61 out of 103 tracked in 2023, massive private investment, $67 to 2 BEAS in 2023, M&A activity, job postings, startup ecosystem, home to most major companies.
A powerful ecosystem. And China's strengths again.
Strong government backing, vast data availability, very high adoption rates, like 83% business use of Gen AI reported, dominance in patent filings, around 70% globally from 2014-2023, developing indigenous chips and models like DeepSeek and Baishuan, huge infrastructure investment. Compute capacity is seen as key.
So clear strengths on both sides. Who else matters globally?
The EU stands out for its focus on regulation with the AI Act. The UK is positioning itself as a leader in research, investment, and particularly AI safety.
Hosting those safety summits.
Right. Canada has major research hubs like Mila in Montreal. South Korea is strong in patents, investment, and chip manufacturing. Singapore is noted for rapid innovation growth. Japan emphasizes government-industry collaboration. And India has a large talent pool and growing ecosystem with initiatives like the India AI mission.
So it's multipolar, even if the U.S. and China are the biggest poles.
But there's a darker side to the global picture: the AI divide.
Yes, the report highlights a significant disparity between the global north and south in terms of AI development, adoption, and reaping the benefits.
Meaning developing countries are being left behind.
Largely, yes. A UN report mentioned over 100 countries are excluded from many AI benefits. Indices like Oxford Insights show the lowest readiness scores in sub-Saharan Africa, the Caribbean, Latin America, and parts of Asia.
What's causing that gap? Factors include the high cost of AI infrastructure and talent, lack of access to large, high-quality data sets, a skills gap, and often more pressing immediate development priorities. There's a real risk AI could exacerbate existing global inequalities.
A serious concern. And amidst all this, we see both competition and cooperation.
It's a mix. Intense geopolitical competition, especially U.S.-China, with things like export controls on advanced chips, but also cooperative efforts like those AI safety summits, UK, South Korea, soon France, bilateral agreements like U.S.-UK cooperation, and ongoing discussions at the UN.
But getting everyone on the same page is hard.
Very hard. Differing national interests, economic strategies, and regulatory philosophies make achieving global consensus on AI governance incredibly challenging. The report includes a table comparing regulatory approaches that really illustrates this divergence.
Yeah, contrasting the EU's Comprehensive AI Act, the U.S.'s more market-driven, fragmented approach, and China's state-centric rules. Different worlds, almost.
Which leads us squarely into the opportunities, the risks, and the ethics, the really big picture stuff.
Okay, let's start with the opportunities. What's the upside potential, according to the report?
It's potentially transformative. Huge economic growth and productivity gains. McKinsey estimated AI could add something like $4.4 trillion annually to the global economy.
Wow. Trillions.
Major advancements in science, accelerating drug discovery, material science, climate modeling, understanding biology, improved services and quality of life through better healthcare, personalized education, more efficient finance and logistics,
Making things work better, essentially.
enhanced decision-making in business and potentially government, and more personalized experiences in entertainment, commerce, etc. The potential benefits are vast.
It paints a very optimistic picture. But then, the risks and challenges.
And the report lays these out clearly, too. Big concerns about job displacement due to automation and the potential for increased economic inequality.
The robots taking our jobs fear.
It's more nuanced, likely changing the nature of work, but displacement is a real concern. Then there's bias and discrimination. AI models trained on biased data can perpetuate or even amplify societal biases in areas like hiring, loan applications, or criminal justice.
That seems incredibly dangerous.
It is. Privacy is another huge one. AI systems often require vast amounts of data, raising concerns about surveillance, data collection practices, and potential misuse of personal information.
And security. Can AI systems be hacked or misused?
Definitely. AI systems can have vulnerabilities, and adversaries could use AI for malicious purposes, creating more sophisticated cyber attacks, automating disinformation campaigns.
Speaking of disinformation, deepfakes.
A major concern highlighted. The report notes hundreds of thousands of deepfakes were shared in 2023 alone. They can be used for fraud, political manipulation, harassment, eroding trust in media and institutions.
That's deeply unsettling. What about accountability? The black box problem.
Right. If a complex AI makes a harmful decision, like in a self-driving car accident or a biased loan application, it can be very difficult to determine why it made that decision and who should be held responsible. Transparency and explainability are major challenges.
And the environmental costs.
Also significant and often overlooked. Training large AI models requires massive amounts of energy and water for cooling data centers. The report cites stats on GPT-3 training emissions and the energy cost of even a single ChatGPT query. It's not environmentally free.
So a whole suite of risks alongside the opportunities. And then the report tackles the big one, the existential question.
Can AI take over the world?
Yeah.
Can it? What's the thinking there?
The concern revolves around the potential development of AGI or ASI, artificial general or superintelligence. The fear isn't necessarily malevolent robots like in Terminator.
No. What then?
It's more about the control problem or alignment problem. If we create an AI vastly smarter than us, how do we ensure its goals remain aligned with human values and well-being?
What if its goals are different? A superintelligent AI might pursue its programmed goals in unexpected and potentially catastrophic ways, even if the initial goal seems benign. Bostrom's famous example is an AI told to maximize paperclip production, ending up converting the entire planet into paperclips.
Okay, that's vivid.
Or it might resist being shut down because that would prevent it from achieving its goal. The core fear is losing control over something far more intelligent than ourselves, leading potentially to human extinction. A 2022 survey found over 10% of AI researchers thought there was at least a 10% chance of an AI-related existential catastrophe.
That's sobering. Is everyone convinced this is a near-term risk?
No, there's significant debate. Some thinkers like Ray Kurzweil predict rapid progress towards superintelligence, while others like Jan LeCun are much more skeptical about the feasibility or timeline of AGI. But the report notes that many prominent figures, including some AI pioneers, are warning about these risks.
So even if the timeline is uncertain, the potential impact means we need to take it seriously.
That's the argument. It's driving a growing focus on AI safety and alignment research, trying to figure out how to build AI systems that are safe, controllable, and beneficial even if they become super intelligent. There are calls for caution, careful development, maybe even international treaties on certain high-risk capabilities.
Thinking ahead about control before we build something uncontrollable, which leads naturally to governance and regulation. How are we trying to manage this?
The report details the main global approaches. The EU's AI Act is probably the most comprehensive.
How does it work?
It takes a risk-based approach. AI systems are categorized: unacceptable risk, banned, like social scoring; high risk, strict requirements for things like safety, data, transparency, oversight; limited risk, transparency obligations; and minimal risk, few rules.
So the riskier the AI, the tougher the rules.
Exactly. And it has extraterritorial reach. It applies to companies outside the EU if their AI affects people inside the EU. It's being phased in over the next couple of years.
Okay, that's the EU. What about the US?
The U.S. approach is much more fragmented. No single overarching AI law yet. It relies more on existing sector-specific regulations, like in finance or healthcare, voluntary commitments from companies, President Biden's executive order laying out principles and tasks for agencies.
So more like a patchwork.
Kind of. There's the NIST AI Risk Management Framework offering guidance, the National AI Research Resource (NRR) pilot project, FTC scrutiny on unfair or deceptive AI practices, and a U.S. AI Safety Institute, but it's less centralized than the EU.
In China.
China has issued specific regulations targeting algorithms, deepfakes, deep synthesis, and generative AI. The emphasis is very much on state control, social stability, and ensuring AI aligns with socialist values. There are mandatory filing requirements for algorithms. They're also investing heavily in AI literacy
There
programs.
are different priorities shaping their rules. So huge divergence globally.
Definitely. And this divergence creates major challenges for international companies and for achieving any kind of global harmonization on AI rules.
What are the biggest regulatory hurdles overall?
The report highlights several. Finding the right balance between promoting innovation and ensuring safety don't want to stifle progress but need safeguards, keeping regulations relevant when the technology moves so fast, harmonizing rules across borders.
And figuring out who's responsible.
Yes, defining and enforcing accountability, especially with complex AI systems bridging that accountability gap, and ensuring meaningful transparency and explainability so we understand, to some degree, how AI reaches its decisions.
These are not easy problems.
Not at all. Alongside formal laws, there's also a growing focus on ethical frameworks and principles.
Trying to define what good AI looks like.
Essentially, yes. The report notes a surprising convergence around core principles for trustworthy AI.
Like what?
Things like respect for human rights and dignity, fairness and non-discrimination, transparency and explainability, accountability, safety and security, privacy and data protection, the need for human oversight, and increasingly, environmental sustainability.
That sounds like a good list. Are these being adopted?
Yes, organizations like the OECD and UNESCO have promoted global standards based on these principles. We see them reflected in national guidelines too, like ethical principles for the U.S. intelligence community or frameworks developed by universities like Colorado State.
But the challenge is making them real.
Exactly. The huge challenge is translating these high-level principles into concrete, actionable practices and verifiable standards that developers can actually implement and auditors can check, moving from what to how.
Making ethics operational. Okay, final major section. AI's influence on learning and human development. This feels very personal.
It really does, and the potential impact on education is immense. The report details personalized learning as a key opportunity.
AI adapting to each student's needs.
Right. Adaptive platforms like Dreambox Learning can tailor lessons and practice based on individual progress. AI can also enhance engagement through things like educational chatbots or AI companions. It might even help accessibility, like robotic assistants for students with special needs.
And helping teachers.
Big potential there, too. Automating tasks like grading, helping teachers identify students who need extra support, providing tools for creating new types of learning content, maybe integrating with VR or AR.
Sounds great. What are the downsides or challenges mentioned?
Several important ones. The risk of bias in educational algorithms disadvantaging certain groups, the concern that over-reliance on AI tools could hinder the development of critical thinking and problem-solving skills.
If the AI just gives you the answer.
Exactly. Also, AI can't replicate the crucial social and emotional learning that happens through human interaction in a classroom. And the digital divide issue, unequal access to these AI tools, could widen educational inequalities.
So it's not a magic bullet for education.
Definitely not. The emphasis should be on augmenting human teachers, not replacing them, and developing AI literacy for both students and educators so they understand the tools they're using.
Finding the right balance. And
Mhm.
beyond the classroom, what are the broader impacts on human development?
The report touches on workforce transformation. We talked about job displacement, but also job creation and the need for continuous reskilling and upskilling as AI augments many roles.
Changing the skills we need.
Right. AI can also improve access to information and services. Think AI tools offering basic legal advice or health information. It can impact societal interaction, maybe through AI companions, but also potentially affect social skills or have psychological impacts from job disruption.
And the potential for good.
It mentions contributing to the Sustainable Development Goals again, but always with that counterbalancing risk of deepening inequalities if the benefits aren't shared widely, that AI divide we discussed.
So again, a double-edged sword. Huge potential, significant risks.
It really is. The report concludes that its impact requires proactive measures to ensure equitable access and maintain a human-centered approach. It's about shaping AI's development consciously.
Okay, that was a lot.
Yeah.
Let's try to pull the threads together.
We've covered a huge amount of ground, tracing AI from theoretical concept to, well, this pervasive force it's becoming.
Yeah, we went through the history, the tech behind the current boom, the major companies and people involved, the incredible range of applications, good and potentially worrying, especially in the military sphere,
Then the global race, the competition and attempts at cooperation, the stark divide between nations.
and landed on those massive opportunities versus the equally massive risks, economic, social, ethical, even existential, plus the challenge of governing it all.
What stands out is just how fast everything is moving and how deeply intertwined AI is becoming with almost every facet of modern life. The choices being made now about its development and deployment feel incredibly consequential.
Absolutely. And for you listening, we really hope this deep dive, based on that AI history impact regulation report, has given you a solid foundation, a way to grasp the core issues without feeling totally overwhelmed by the complexity.
Because understanding these fundamentals, the capabilities, the players, the stakes, is becoming essential for navigating the world we live in and the world that's rapidly emerging.
It's not just tech news anymore. It's impacting society, economics, politics, maybe even what it means to be human.
It really does feel like a fundamental shift comparable to previous technological revolutions, but perhaps even faster and more profound in some ways.
So here's a final thought we want to leave you with. Mull this over. Given the sheer speed of AI development and all these profound questions it raises about jobs, fairness, truth, control, our future,
Hmm.
what single aspect of AI's ongoing evolution do you personally think deserves the most careful attention right now, and why?
It's a critical question, forcing us to prioritize where we focus our collective efforts as individuals, organizations, and societies in steering this powerful technology towards outcomes that truly benefit humanity.
Definitely something to think about.
Yeah.
Because this story, this AI revolution, is far from over. It's happening
Yeah.
now, and staying informed, staying engaged is going to be crucial for all of us. Thanks for joining us for this deep dive.